Welcome back, class. Today we're going to be talking about building quadratic models, which means we're going to combine some of our prior knowledge of quadratic functions with what we were doing in the last unit where we were trying to build these multivariable functions in terms of a single variable. Our first example is actually about revenue. And as a quick reminder, revenue is the amount of money essentially that a company is going to take in. To find revenue, we're going to need to multiply the number of items sold times the price of each item. Now, if we read the problem, the city of Chicago has found that when Bears jerseys are sold at a price of P dollars, so first of all, let's make note that price is the variable P, and the number X of jerseys sold each week, so the number of items is the X variable. The number of items sold at a particular price are given by this demand equation. So this is the equation that is essentially relating the number of items and the price. You'll notice that this equation does not mention revenue. It's not telling us how much money they made. It's telling us how many items will be sold based on the price of each item. So our job is to first express the revenue as a function of X. Well, a couple of things. Remember that we know that the revenue equation is the number of items sold, which in our case is X, and we're multiplying that by the price, which in our case is P. So if I started initially with a very simple equation, the number of items sold is X, and I'm going to multiply that by P. There's my revenue equation. But now I have to go back and I need to rewrite this equation in terms of X, which means I need to get the P out of the equation and I'm going to have to replace it with something else. Now, some of this is going to take a little work, so I'm actually going to move down to the bottom to show some of my work. I have this equation, X times P. I'm trying to remove the P from the equation and I need to replace it with something. So if I go to the demand equation that we were given, this was the equation that compared the number of items sold based on the price. If we were to take this equation and solve for P, so in other words, we are going to isolate the variable P, I can subtract 5,000, divide everything by -8, and in terms of how you write this, x divided by -8, I'm going to write that as -1/8 x, and 5,000 divided by -8, -5,000 divided by -8 is just a positive 625. So now I know that the variable P can actually be replaced with this quantity, and I can plug that back into my equation. So my new revenue equation says X times, in place of P, I'm going to put -1/8 x plus 625. Okay, and then we're going to simplify a little bit by distributing that X. That's -1/8 x squared plus 625x. Now, just from looking at it and using our knowledge of parabolas, we can tell that this is a parabola because it's an x squared. We can also tell that this is a parabola that is opening down because our a value is negative. So we don't know much else except that it's a parabola that looks like this. And because it's opening down, we know that this vertex is going to be a maximum value. Now, the next question that it asks is, what is the revenue? So we're solving for the R value if 2,000 jerseys are sold. Well, remember, the number of items sold is X, so I'm basically giving you an X value, and I'm saying plug this into the equation. Our equation was -1/8 times X squared plus 625 times X. And if we put that rather large thing into our calculator, we're going to end up with a revenue of $750,000. Now, that seems pretty good, but the question is that the maximum? Okay, the next two questions are talking about what is the maximum revenue, but they're worded differently. The first one is how many jerseys can we sell or should we sell to get the maximum revenue? The second question is actually asking for the maximum revenue. Well, thinking back to this graph, We know that this maximum value is going to have an x and a y value to it. We know that x is representing the number of jerseys, and in our equation, the y was actually the revenue. So once we solve for this vertex, we're actually going to know both the number of jerseys and the maximum revenue. So we're going to solve for the vertex. Now we can do this one of two ways. We can find the vertex by hand, since we've learned how to work with quadratics, or we could graph it on the calculator and find the maximum there. I'm going to find it by hand first. Since this equation is in standard form, I'm going to use the formula opposite of b over 2a to find the x value, and then I'm going to have to plug that back into the equation to get the y value. So back up to our equation. For my x, I'm going to do the opposite of b, which was 625, over 2 times a, which was negative 1/8. And if I do negative 625 divided by negative 1/4, that's actually going to leave me with 2,500, whoops, one too many zeros there, 2,500. So there's my x value, there's my x value of my vertex. Now to get the y value, I have to go back to the equation and actually plug that 2,500 in, plus 625 times 2,500. So we're going to have to plug this into the calculator, and what we should get is $781,250. Okay, so there's our vertex. Now when we interpret that, remember that the number of jerseys was the x value. So for the number of jerseys sold, we need to be using this x value. If I go back up here, that means 2,500 jerseys must be sold to maximize profit. And the maximum revenue is the y value, which here was the 781,250. 250. Now, if I wanted to check my work, or if I wanted to simply use a calculator, I could switch over to either a graphing calculator, or I could switch over to Desmos, and I could graph the equation on here. If I'm graphing it on the calculator, actually before we do this, if I'm graphing it on the calculator, I am going to want to consider what my domain is, because that way I can limit the calculator, I can restrict the screen to only show me a reasonable domain. To think about the domain, we need to go back and think about this parabola that's opening down, okay? We know now that this parabola opening down has a vertex point at 2,500 and 781,250. So we know this rather large vertex point. And we know that the parabola is opening down. What we don't know is where does the parabola actually cross the x-axis, and that is going to be important to our, that is going to be important to actually determining what our domain is. So I'm going to go back and say, if this is my quadratic, x squared plus 625x, and I want to know where this parabola is actually crossing the x-axis. I want to know my x-intercepts. I am going to set the equation equal to 0, and I'm going to factor it in order to find the x-intercepts. We learned earlier in the unit that one method of finding the x-intercepts is to factor it. So if I factor out a negative 1/8 x from both terms, that's going to leave me with an x minus 5,000 inside the parentheses. Using the zero product property, if I set negative 1/8 x equal to 0 and x minus 5,000 equal to 0, my x-intercepts are 0 and 5,000. So let's think about our parabola here. We know that our parabola has x-intercepts at 0 and 5,000. We know the vertex point, which was right here, that was our vertex point. And again, the reason we needed these x-intercepts is because our x values, the number of items sold, can't go past this x-intercept, because if it does, the revenue would then become negative. Okay, so what is our domain? our domain is going to have to be from 0 to 5,000. And again, that domain is going to help us to be able to graph this and find that maximum value on the graph. If we go back now to Desmos, and we wanted to graph this function, just to confirm our values, we have y equals, let's do parentheses, -1/8, close our parentheses, x squared, oops, need that out. Okay, so we're going to go out, close our parentheses, then we can do our x squared plus 625x, and I'm going to go back up and change my domain or my window to 0 to 5,000. And from my step, in other words, what I'm going to count by, since I'm going up to 5,000, I think I'm going to count by like maybe 500 here. And we'll see what this looks like. Okay, if we're having trouble seeing the graph, you can always squeeze in a little bit. Okay, we want to see the top of that parabola. Can always slide it down. It's getting skinnier. Okay. Let me try zoom square here. And let's try this again. 0 to 5,000. There we go. Okay. Gives us a little bit of a better picture. We don't have to scroll all the way up there. Okay. Looking for that maximum, there is that. Now it looks like it's a little bit different than what we had calculated by hand. We've got 2,800. Oh, nope, there we go. 2,500 and then 781,250, just like we had established before. So it's a quick way that we could check our work to make sure that our original vertex was accurate, okay? The final question, what price should the city of Chicago charge to maximize revenue? So think about what we know at this point. We know that we need to sell 2,500 jerseys. We know that the maximum revenue, or I'm sorry, we know that the maximum revenue that we will make if we do that is $781,250. What this is asking is what price do we need to charge in order to maximize that revenue? Well, if you think back to the original equation compared the price and the number of items sold. So if we go back and look at that original equation, minus 8p, if I know that I'm going to be selling 2,500 jerseys, I can solve this equation for p. 2,500 minus 5,000. Then if I divide by -8, looks like the price per jersey is going to be $312.50. Now, another option for figuring out the price is thinking back to the original equation. Revenue is the number of items sold times the price. So if I know that I want the revenue to be $781,250, and I know I need to sell 2,500 jerseys to make that happen, if I do 781,250 and divide by that 2,500, I will also get a price of $312.50. So there's two different ways you can calculate the price afterwards, but it's all based on the revenue and the number of jerseys. Okay, so there was example 1. There's a lot of information in here, and I'm going to give you some time to digest that, and then we're going to be looking at example 2 and 3, which really are taking that same idea, but then working with area instead.